They pick it up so quickly. After a 10-minute introduction on day one, my students spend the next 20 to 30 minutes just playing and exploring the program. They learn the best by clicking on different things and seeing what happens, and they'll find the words for the transformations and they'll explore to see what happens.
And I let them explore first, and then I give them a little bit of guidance on, let's try constructing a circle, let's try constructing a line segment versus a line. I like them to share what they've experienced and to help each other in partners or small groups.
We just simply have to allow time for the students just to sit down and just play for a while.
8th graders are full of enthusiasm, and anytime you use a new approach with them, they tend to respond very favorably.
I mean, the kids are so much more adept at using the computer than my generation was. That, you know, it's a new computer game.
What I've done for many years as an introductory activity is the footprints, because the kids have a lot of fun with it. I have them really come up with a definition of reflection, what it means to reflect an object. And they end up thinking it's really exciting. They change all the colors. And because they like making the footprints go across the screen so much, they do learn a lot about the software that way.
First time I do something called a flying triangle and just introduce them to some of the neat things that they can see. It's animation, it's color.
The very first day they do an activity about line and angle relationships. It's guided, it's a directed activity where they're drawing lines, constructing parallel lines, measuring angles, and just kind of getting an overview of a lot of Sketchpad features without having to do anything that's really difficult.
It's really easy to get into. They make a lot of points. And then they very quickly identify the animation tool. So they make a window around all those points that they created, and they animate them all. And, so they have a whole bunch of flies buzzing around the screen, which everyone enjoys. And then, we give them a slightly more challenging problem, which is, make a square. And then, they make a square, and then we come around and mess them up. And then we say, okay, now make one that I can't mess up.
After our hands-on constructions, we would go and use Geometry or Sketchpad. And with that, they would be able to manipulate any of their handmade constructions, but see accurate measurements and be able to prove theorems with that.
I use it as a demonstration tool in class. Sometimes it's just not practical to move 30 kids from a classroom to a lab. So I have a laptop that is loaded with Sketchpad, a camera, and I'm able to often I will pre-make the sketches. We'll use it as a demonstration tool. And I even use Sketchpad to, when I'm making up test quizzes and worksheets, I make the figures and then I cut and paste them and import them into my own documents.
I use it a lot for all my tests. I couldn't do it without the software. I don't know how else I would draw the graphs. I import what I have into Word.
There are some times where perhaps we'll do more of a student-directed activity in the classroom, and then the Sketchpad lets us go to the lab and we can do an activity that will enrich or extend whatever it is we've done together already in class. So, I have found an electronic version of the pantograph that will take away some of that experimental error. So, the first part of it is just plain reintroducing the dilation tool of the Sketchpad. The second part has you use a lot of the Sketchpad features in order to create a electronic pantograph.
How am I supposed to make that the radius?
Select them. Look, read over here on the left.
Really, you can make it as long as you want. They would have to go in there and be like segment, gray, and just line. They would have to tell you, but after you got it, it's pretty simple.
I asked you a question before we started. Could you explain to me about congruence versus similarity? Let's talk about some of the ways in which the two concepts are the same, some of the ways in which the two concepts are different. Tell me some of the things that you've learned.
Okay, if the image is similar, the image stays the same, but size and other features can change. And if the image is congruent, it is an exact copy of the pre-image.
The size of the dilation depends on the distance from the point of origin. If AB is smaller than AC, then AC is larger than AB.
If two shapes are congruent, like they're exactly the same, if they're proportional, then if they're similar, they're proportional, but they can be congruent and similar, and like that proportion would be 1.
After the students have learned how to use the software, then it becomes a tool for enriching, and it actually speeds up the instruction.
If you don't know what you're doing, don't worry about it, because you can't mess it up on day one. Day one's all about getting the points on the plate and just seeing what you've got.